This is the selector Rapidstrike board. This guy grants you select smart control for your Rapidstrike in either a pusher motor or a solenoid. This guy also gives you variable rate of fire. I've already made an overview video covering all the features and what's on the board itself, and this video will go over how to install this kit into your Rapidstrike. In the future, I'll also have a full complete walkthrough from beginning to end on how to install this kit and overhaul a stock Rapidstrike. I also have planned an extended overview of this board where I'll go over a lot more of the complex electronics and software that powers this guy. So these are the parts and components you'll receive with the kit. It comes with everything you'll need to get your blaster up and running. Here's the select fire board. It comes pre-programmed and pre-assembled with all the components soldered on. And you also get this little bag full of small switches and connectors and wires that you'll need too for the switches and stuff. In the bag, you'll get 3 of these connectors with wires on the end. This is for your power switch, your trigger, and for your cycle control switch. And they plug in super easily into the board. They come in pigtails, so all you have to do is solder these guys onto whatever you want, and they simply click into the board really easily. They're polarized, so you can't put them the wrong way, and you just click them in place. No soldering onto the board itself required. They also have these plastic little shrouds around them to keep them in place during motor vibration so they don't come out. And these are the same connectors I use on the MOSFET boards and the PWM boards. You'll also get a 5-pin connector. This is going to be for the select fire switch. These wires are really long, so you can just cut them down in place. This is for other blasters besides the Rapidstrike who want to use this kit. So you can simply take these wires and cut them to whatever length you need. You'll get a rotary switch. This is your select fire switch, so it spins in like a circle. And there's 4 positions, 1 for every fire mode. So there's safety, semi-auto, full auto, and burst fire. You'll also get a cap for the rotary switch that snaps right on. It's friction fit, and it's actually pretty tight. When it's secured in your blaster, you can simply flick it with 1 finger to get it to the exact position you want. You can also 3D print your own knob to better emulate a select fire switch like a real one. But this is what's offered in the kit. You can simply pull it off, and you'll also get a this is the 2-position switch. This is for your power switch, so you can turn your blaster on and off. You'll also get a small little jumper cap. This won't be needed in all builds. This is simply for you to put right here in these 2 little pins. Simply press it on. And this lets you know that the blaster is going to be in solenoid mode. So this is how you switch between solenoid mode and pusher motor mode. You can simply pull that off. And you also get a few washers and nuts. These are for securing your rotary switch and your power switch in place. If you selected the variable rate of fire option, which allows you to achieve different rates of fire depending on the knob, you'll receive an included knob as well. So this guy has a 3-pin connector, because the knob only has 3 pins. You get a little cap and the knob itself. You'll also get these 2 washer and nut to secure your knob in place. Knobs are the same deal. You can actually swap them with your select fire knob in case whichever one you like better. Let's talk about switches. Because this kit has built-in MOSFETs, you have the option to use these stock switches. If for some reason you don't want to, that's totally fine, and that's all up to personal preference. And this board will also work with your upgraded switches. So you have 2 options. You can either retain all the stock switches, or you can swap them all out. I personally think that's easier to keep the stock switches because I'm more comfortable with electronics over mechanical mods. If you're more comfortable with mechanical mods and you feel comfortable drilling out and mounting every single switch in place, you can also do that. If you use all stock switches, you'll need to use a MOSFET for the flywheel motors. Now you can solder your own MOSFET, or you can use your own MOSFET board, which makes everything a lot easier. And I'll go over how to do that a bit later. If you want to use all upgraded switches, you will not need a MOSFET for the flywheel motors. There is no high power flowing through the cycle control switch, and there is no high power flowing through the main trigger switch. There will be high power flowing through the rev switch, because this is going to control the flywheel motors. Remember that the flywheel motors are not controlled through the board, and you have to control them manually. That means through a rev switch, as it is traditionally done, or through a MOSFET. I'll go over all my recommended setups a bit later on And you can find more info about this on my FAQ section on the shop page. When soldering to the cycle control switch and the trigger switch, you'll want to solder these cables to the common tab and the normally open tab. That's COM or NO. It doesn't matter which wire goes to where, but as long as one wire goes to the common tab and the other wire goes to the normally open tab. If you're using a stock switch, it matters that one wire goes to the center pin and the other wire goes to the rightmost pin or the backmost pin. You may also notice that some of these Rapidstrike switches have 2 rows, so make sure that when you solder these onto the stock Rapidstrike switches that both wires are on the same row. Be sure to heat shrink all your connections too. So to reiterate, you want to solder 2 wires for the cycle control switch and for the trigger switch to the COM or the common and the NO or normally open tabs of the switch. If you're using a stock switch, that means you'll be soldering to the middle pin and to the backmost pin. And if you're using a stock switch, you want to solder all wires to one row or the other. You don't want one wire to be on the top row and another wire to be on the bottom row, because that will not work. Once you've got those done, simply plug them right in. Soldering the select fire switch is a bit tricky, but it only takes 5 solder joints. So first thing we're going to do is identify the common tab, or the common wire on the board. So let's just take a connector, nothing plugged in yet, and take a board and just plug it right in. Now if you look really closely, there's a small COM text right there. That means that the leftmost pin, this is the common wire. Just remember that the red wire is a common wire because that will become very important a bit later on. Now I can't tell you specifically that the red wire will always be the common wire because different connectors have different colors for every single wire. So just remember that after plugging it in, the leftmost wire is the common wire. And remember the color too, because once you unplug it, it can get kind of confusing if you're saying the leftmost wire, because there are so many orientations from. So now we know that the red wire is the common wire, and we'll want to solder this common wire onto the common tab of our switch. So our switch has like a bajillion holes in them, or a bajillion tabs in them, so that's why it can be very challenging or confusing to solder to. So I made this really quick and indicating which tab is the common tab. So this is looking at the switch like this, and as you can see, the upper right tab is a common tab, and the lower left tab is a common tab, which means it's this one and this one. That means that the red wire has to go to either one of them or the other one. It doesn't matter. So once you've soldered one wire onto, let's just say you soldered the one onto this bottom one, that means you have to solder the other 4 wires all onto the same row. So which means that if you solder the red wire or the common wire onto the bottom row, you'll need to solder all the other wires onto the same row. And when wiring it up, you want to make sure it's in order. So right now the order is red, black, yellow, white, green. So when you solder it, you of course have your red common wire, and right immediately next to it, you put the black wire. This is the same order. And right after that, you'll get the yellow wire, and right after that, you'll get the white wire, and so on. So you just want to make sure that it's in order. So if you solder the common wire onto this tab, to reiterate, you want to solder the wire right next to the red wire onto the pin right next to the common tab. So remember that you'll be soldering to the same row. Now if you want to do it for the top, you of course put the red wire on the upper right hand pin and the black wire right next to that, and the yellow wire next to that, and so on. So the most important things you have to remember are where the common wires go and what they are. When you solder the common wire, you'll need all the other wires you soldered to be on that same row. And you want to make sure that when you wire them up, it follows the correct order of the connector. So if you have the red, it goes red, black, yellow, white, and green, or whatever color it's in. Just remember that the red goes here, the one next to the red goes here, and so on. It's relatively straightforward, but if you mess up the order, you can get funky orders for the select fire switch. So right now, if you soldered it correctly, you should have one of the most absolute positions, which is like all the way to the right or all the way to the left. That should be safety. And the one next to that is semi-auto. And the one next to that is burst fire, and the one next to that is full auto. And it's going to be reversed depending on which row you solder the wires onto. So let's say if you solder the wires onto the top row, then the leftmost position will be safety and the rightmost position will be full auto. While if you solder all the wires onto the bottom row, you'll have the rightmost position be safety and the leftmost position be full auto. Be sure to heat shrink all the connections, and you don't want to short anything. If you solder the wires in the wrong position, then you can either have a messed up behavior, so which means that nothing will work, or you can have stuff where it goes from safety and then it goes to full auto, and then it goes to burst fire, and then it goes to semi-auto. So you can get a messed up order. The blaster may still work, but you'll get a messed up order. So once you have all the wires soldered up, it should look something like this. I like to heat shrink all the things together, but I cut it a bit so I can remove it, so I can see every single individual wire. So if we're looking at it like this, this is on the bottom row, which is COM. So in this case, the orange wire is a common wire, and we can double check that by plugging it in. Orange wire is the leftmost wire, and it's labeled COM, so we know it's the common wire. And that goes to one of the corners. And then after that, we have every single one of the other wires in order. So it goes yellow, white, red, and black. Once you have those good, simply put that in there, and you're good to go. Now, inside the shell can be pretty tight, so this overall heat shrink piece is not entirely necessary. Once you get that wired up, simply drill a hole big enough to fit the diameter of the shaft. Once you slot that through, you want to put your washer, and you want to put your nut over it. Now, depending on the friction fit of the hole you drilled, you might not need these, but it's available and it comes included in the kit if you need it. And simply tack on the switch and you're good to go. Now, here's my preferred position, so I can remove this guy real quick. You can see all the way in there. There's my select fire switch. So I simply drilled a small hole in there to fit it through. And if we look over on the other side, I can actually pop this guy off so you can see the hole that I drilled. And the hole was pretty tight, but I just added the washer and nut just in case, and that's about it. Wiring up an optional power switch is also really easy. With the provided 2-pin connector, you want to solder one wire onto the middle pin and another wire onto either the left or the right pin. It doesn't matter which pin, the left or the right, the other wire goes to. It just matters that one wire is in the middle and the other wire is either on the left or the right pin. It also doesn't matter which wire goes where. So you can have the black wire or the red wire in the center. Once you've done that, don't forget to heat shrink. And here's what you'll end up with. Notice how when I flip it around, the wire goes from the left side to the right side. And it's also the same with this dial, where it's more of a lever switch as opposed to this one, which is a slide switch. After wiring up your power switch, simply drill a small hole that's big enough so you can flick the switch. And make sure the nub actually pops out and protrudes from the other side of the shell so you can strike it when the blaster is closed. When mounting it, and to secure it in place, you can use something like epoxy putty or hot glue or just some nuts and bolts. Just remember that if you look closely, you can see that there's a little piece in there that actually moves back and forth physically. So make sure you don't glue that piece that moves back and forth in place. Now, just a reminder that the switch is actually optional, so the blaster will be completely fine if you don't include this switch. I personally prefer not to include this switch, but it's included if you want to use it. Now, here comes probably the most intimidating step. It's not the hardest. I would say the rotary switch is the hardest, although it's not difficult. This is the most intimidating part because you're going to be soldering directly onto the board, which is something that I know not everyone's comfortable with. Luckily, there are only a maximum of 6 holes you'll need to solder directly onto the board. So if you look closely, there's a little text here that says where to solder which wires. So for the battery, you have the negative and the positive. For the pusher, you have the positive and the negative. The pusher polarity actually doesn't matter, but in case you're in a situation where the polarity does matter, where the direction matters, you know which direction to solder these in. This applies for the solenoid as well. Solenoids don't have a polarity, so you can solder either wire to either one. The only ones that do have a polarity are the battery, so you make sure to get that one right. It's positive on the right side and negative on the left side. And the flywheels also have a polarity. Because remember that if you swap the polarity of the flywheel motors will spin the wrong way, so your dart won't fire. And I've also labeled them on the back as well, just in case you want to solder like this way or that way. Soldering directly onto the PCB itself can be kind of intimidating for some people, so I'll go over it here. Luckily, there's only a maximum of 6 holes you'll need to solder onto the PCB itself, minimum 4 for proper operation. I like to use some helping hands, and I'll be demonstrating this with a 13-inch wire that runs from the board itself all the way to the battery. This is about 33 centimeters. When soldering directly onto the board, when soldering wires at least, I like to use thicker solder. This one is 0.032 inches or about 0.8 millimeters. This also is flex core and has a lower melting temperature. Your ordinary solder should be fine, but these are the kind of specs I like to use to make soldering bigger things easier. I also have a temperature controlled iron, and I'm setting it to 750 degrees Fahrenheit. So after you've wired up your XT60 connector or whatever you decide to use for your battery, here I'm using 16 gauge wiring. These holes actually perfectly fit 16 gauge wiring. 16 or 18 works. 14 is a bit tight on the holes. You want to strip and tin the ends. So after you've done that, let's get to soldering. I have just this really simple helping hands over here. Just 2 hands. This is like super cheap one from Amazon for like 10 bucks. I like to hold part of my board first. Make sure you don't clip anything on the other side of the board because you don't want to accidentally remove any of the components. And let's do the negative side first. Because I'm right-handed, I like to solder from left to right, just like how you write with the pen and paper. So if you're right-handed, you would go the opposite direction. This is so I get to solder the left hole first, and then I can solder the right hole. Because if I solder the right hole first, it actually gets in the way when I solder the left hole. So simply put this wire through the hole. I do it from the bottom because if I solder it on like this can actually get in the way of the magazine and stuff in the blaster. So just be careful when soldering. Make sure you know which way the wire should run. Because remember that the board also serves as a wire guide to protect your wires from being hit by the magazine. So any wire that runs beneath the board should be safe from being hit by the magazine. So I like to hold one hand for the board and the other helping hand for the wire underneath. Make sure the wire goes as through as possible. Make sure it's flush with the board itself. Perfect. I also like to make sure that the board is level with the surface I'm soldering with. So this allows the solder to cool and smooth out evenly as it flows, because remember it's liquid when molten. So while cooling, you can sort of get that liquid to flow around while cooling if your board isn't level. So after tinning your tip, I like to put a little bit more on the iron itself. When I'm soldering bigger stuff like this, simply rest your tip where the circle meets the wire and simply tap on a bit more solder and let go, and perfect. That's it. Now if you can feel the board with use maybe the back of your finger, it gets a little bit warm, so you want to allow the board to fully cool down before soldering your next connection. This is so you don't burn or damage any of the components on here. Now while we're waiting for this joint to cool, notice how it's shiny and there's solder all the way around that wire. This is exactly what we want. Sort of like a volcano. Perfect. Now I'm using leaded solder, so it's going to be shiny. If it's not shiny, you can try again, but it's not a huge deal. You can give it a little tug and it's not falling out, which is good. And because the wire is so thick and there's so much solder on here, you actually have a very, very good mechanical connection. So during vibrations, it shouldn't fall off that easily. I'm actually giving it quite a bit of force while pulling it, and nothing, because there's so much solder bonding the wire to the board together. If you can see here, there's a little bit of flux residue around the connector, or around what I just soldered. And there's little balls of flux. The solder I'm using is flex core, and it has a good amount of flux inside. This means you're getting more fumes, which are bad for you, but it also makes soldering a bit easier. The board itself is white, so the flux will be more apparent since it's sort of brownish yellow color. You don't need to wipe that off. If you want, you can scrape it off, or you can use isopropyl alcohol. I usually leave it on though, unless I'm selling the board or something, then I would clean it. Just give it a quick touch, and it's back to room temperature. To unclip this first wire, get in the second wire, thread it through the hole. Notice how the holes are also labeled plus and minus, and batteries and flywheels and pusher respectively. That on. And it's going to be the same procedure. Make sure the board is as level as possible. In addition to tinning our tip, let's get a bit more solder on there. This is for better heat flow from the iron itself onto the board and onto the wire. Simply tap the soldering iron right where the wire meets the board and add extra solder on there. You don't need to add extra flux because the solder should have flux inside it. Perfect. Notice how a bit of that flex came off and it's sort of a brownish yellow color. That's perfectly fine. You don't need to worry about that. It's just a little bit of extra flux that flowed on. The flux actually becomes liquid when melted, and it hardens up. It makes the board look a bit uglier, especially since it's white, so it's easier to see, but not a huge deal. And just repeat that for all the other holes. Most important tips, allow the board to fully cool before soldering. You don't want to damage any of the components on there. Take your time, be patient. Use a good amount of solder. You don't want to add too much because it can actually bridge to another hole, which could mess up the behavior or even damage the board. Use a high temperature iron if possible. That's highly recommended. If you don't have a temperature controlled station, that's not a huge deal. You can still perform this soldering task with ease. If you can solder wires onto switches, you can solder these wires onto boards as well. If you've opted for the variable rate of fire option, you'll get a potentiometer knob. This includes a connector, the knob itself, a cap, and of course the washer and nut. If you're familiar with wiring the potentiometer from the PWM module, it'll be exactly the same. So once you have your knob, just take your little cable. You want to plug in the center wire to the center pin of the knob, and the two left and right can go to either side. It doesn't matter. What's important is that the center wire of the connector goes to the center pin of the potentiometer, and you solder these two both down. After you have that and you heat shrink everything, it should look like this. Notice how the center wire, which is white, goes to the center wire, the center pin of the knob, and the two other wires can go either way. Now when mounting this, simply drill a hole that fits the diameter of this and put in your washer, put in your nut to secure it in place, put in your cap, and you're good to go. So let's see how to assemble everything once you have all the boards and the switches wired up. So here's the empty shell. Do a first quick test to make sure everything works, fits well. Everything's good. So the board rests in here, but I like to put in the rotary switch or the select fire switch in first because that's usually the hardest to install. And now notice how I soldered all the wires onto the bottom row, just because that makes installation a bit easier. And simply push that in. And go to the other side and secure it down with the washer and nut. Pop on the cap, and you're good to go. If your cap is in a weird spot, meaning that like you want it to rotate a bit differently, you can simply take it off and put it differently. There you go. Now you notice how the nub is around this area as opposed to this area. Do some simple wire routing. Now here's how I like to route my wires. If I put in my pusher temporarily real quick, notice how there's a tiny little gap right here. This is where I route all the thin wires through. That includes that for the rotary switch and for the trigger switches as well. So because of that, I usually put in the pusher motor a bit later. So I have a general area of where that should go, which is right here. I install the rotary switch first because it's like all the wires rest above it. Next, I like to put in the board. This is because for the pusher switch, or for the pusher cables, the pusher cable should run on top of the cables for the rotary switch, but below the cables for the trigger switches. And notice how you can actually tuck the wires underneath the board. Remember to use the following channel over here. You might need to remove one of the locks from the switch plate to do so, and make sure the battery wire goes off to the other side. You can run it in here if you've created the hole, or down here, and put that in place. You can screw it on now, but it's still a good fit without the screw. After you screw it in place though, you make sure to do a magazine test to make sure that your magazine goes in all the way and isn't hit by whatever's on the board. So after that, I like to put in this guy, the pusher box, and make sure that the wires for the rotary switch are properly mounted in place, right in this little area. Now I screw in the screws a little bit, but not all the way. This is so the screws don't fall out. And notice how I routed the pusher wire underneath the pusher itself, so you don't have to go around. If you have the wire go around, you actually will not be able to retract the stock. And plug that guy in. If it's a bit too long, like what I have here, there's a bit of extra space so you can route the wires. So I just pull mine like that. And let's do this guy. This is the switch plate. So I like to route the cycle control wire a bit underneath, like so. A bit underneath the cycle control nub. And same thing with the trigger switch. I run these both under the cycle control nub. I don't snap it into place just yet. Remember how I didn't screw in the pusher itself all the way? So I lift it up a bit and I squeeze in the wires one at a time into that slot. So simply thread it in like that. Make sure you don't tangle the wires too much. Just one at a time. If you do two at a time, it might be too thick. It'd be a bit more challenging that way. Let's do a quick check to make sure all the wires are in place. So if you look closely from the top, all the wires are tucked into place, and from the back as well. Once you know that's good, just simply screw in the motors, or simply screw in the pusher, and now it's secure in place. Once you have that, mount your cycle control switch. And that's it. Plug in these guys, and you're good to go. Preparing this kit for solenoid operation is actually even easier than for using a pusher motor. So the first thing you want to do is, you see those two pins right there? It says pusher mech select. You want to put a jumper cap right there. And of course the jumper cap is included with the kit. Once you have that done, tuck the board back into the shell. You want to plug in your rotary switch and only the trigger switch. You actually don't need the cycle control switch for this. Let's do the knob, and of course the battery and the solenoid. Remember, the solenoid doesn't have any polarity, and you'll want to solder the knob, the select fire switch, and the trigger the same way as described previously. Here's semi-auto, here's burst fire, and here's full auto. So after wiring up the pusher motor, the cycle control switch, the trigger, the select fire switch, and the knob, we have one last thing to do, and that's the flywheel motors and the flywheel setup. So you can see here, there's a few holes that are labeled flywheels, and there's a plus and a minus. You can treat these holes as if it was a regular battery and solder your setup accordingly. So if you wanted to use a micro switch, you'd go ahead and solder it like this. This is just your traditional setup where you have your two motors in parallel and your switch in series, and the switch cuts off power to the motors. And you solder the positive side to the flywheel plus and the negative side to the flywheel minus. Remember, if you use this method, you'll need a high amperage rev trigger, and that's for the rev switch. And you have more options with if you use the MOSFET board. So here's how I prefer to wire up the flywheel motors. I like to use a MOSFET board. I sell these on my shop, and these were the first products I offered. They allow for a super simple flywheel build, and I get to keep the stock switch since I find it very troublesome to carve out all this area for a rev switch. So super simple. I already soldered on the connector for the flywheels plus and minus. So we just have plus go to plus, minus go to minus, and we're going to pretend this is the battery. So of course we want to take the correct connector that goes to the battery. This is the XT60 female connector, and we're going to plug that right into the battery side of the MOSFET board. And you can use XT30s or Deans whatever you want for these. But the MOSFET boards include built-in XT60 connectors. Make sure you don't tangle the wires too much. There's an option for a master switch, but I usually don't use a master switch. Personal preference, so I plug in a jumper cap to bypass that. This is all included with the MOSFET board kit. There we go. Let's plug in the rev trigger. These are the same connectors that are on the selector board. So the same amount of soldering is required, but I'll drop in the links in the description below for where to buy this in the installation video. And plug in your flywheel motors. Once you got that, don't forget to plug in our battery, and we're good to go. And if you have it this way, you can mount this right here and be sure to move the wires around accordingly. You can route them underneath the board or wherever you want. I usually like to place my MOSFET board up here and extend out the wires to the flywheel cage. Now, if you want full versatility, you can get variable pusher speed and variable FPS using the PWM module. That's this guy. This guy is another part of the MOSFET board ecosystem. So to achieve variable FPS, you just have to put the PWM module in a motor mode. So this PWM module offers either PWM motor control, which means you can get variable speed on your motor, or you can get select fire solenoid control, but you don't get burst fire. I'll leave links to this guy, of course, in the description below. That includes the store link where to buy it and the installation guide I made. So there's text really close there. If you look at the bottom, it says motor, so I put in a jumper cap right there where it says motor. All these parts are included. See, I'll put in another jumper cap right here on these first top two connectors. I'll plug in the knob. The knob's included, of course. And lastly, I'll plug in the rev trigger where the trigger goes. And this guy literally just stacks right on top of the MOSFET board itself. So you see those 3 pins in the bottom, you simply mate them together and you're good to go. So if I pull the trigger, so in this case, you can actually hear the motors like becoming louder and quieter depending on how fast they're going. So you can just tuck this anywhere in the blaster, and you have the most versatile Nerf blaster you can get. You can get 170 FPS out of this guy. You can get a dart hose of like 18 to 20 DPS out of this guy. And you can change those are all variables you can change with these knobs. And that's the benefit of this Rapidstrike board and all this ecosystem I've developed around the MOSFET board. So you can simply plug and play these things together, stack boards on top and connect boards together if you want more features. But if you don't really need those features or you don't want to pay the extra money, you can simply, everything works as bare bones as it can be. I'll also go over more of the ecosystem part in the in-depth overview of the Rapidstrike kit. So I'll show you how to use the expandable headers and how to program your flywheel motors to do a more complex control. And that's about it. I hope you enjoy your new fully decked out selector Rapidstrike. Stay tuned for future videos on this Rapidstrike kit, including a complete walkthrough from start to finish on how to overhaul your Rapidstrike, starting with a stock Rapidstrike, and also an extended overview where I'll go over more of the electronics and software of this kit. I'll have links to everything down in the description below, so be sure to check them out. If you have any more questions or comments, feel free to leave them down below. That's about it. Thanks for watching.